Your Java application has plenty of memory, yet it still crashes with out of memory error. Why? Because you don't actually understand how JVM memory works. This is part 1 of my Java garbage collection series. Here I will break down stack, heap, and metaspace, the foundation of everything that GC does. Now, let's start with stack memory. Think of stack like a notebook for a single method execution. Each thread has its own stack. It stores method calls, local variables, primitive data, or object references. Here, if you see that integer variable, these are primitive. Integer, boolean, all are primitive. These are stored in stack memory. But for objects, only the references are stored, like P1, P2, and str1 here. So these are all references. These are stored here, but all the main objects are stored inside heap memory. So in stack memory, it allocated and freed automatically, while method enters or exits. It is very fast, but limited in size. For heap memory, this is where the real action happens. So it is shared across all the threads. It stores actual objects like here P1, P2, and this string. So all are real objects. This is stored inside heap memory. It is bigger but slower than stack, and it is managed by garbage collectors. So stack store the references while heap store the actual object. Now let's summarize stack versus heap. So stack is thread local, heap is shared. Stack is fast, heap is relatively slower. Stack is small, heap is large. Stack automatically cleans up its memory, but for heap, we need garbage collector. Next, let's understand heap memory architecture. Heap is not one big block. JVM divides heap into generations based on very important observation. It is called weak generational hypothesis. Most objects die young. Heap is divided into two main parts, young generation and old generation. Let's understand young generation first. Young generation is also divided into two parts, Eden space and survivor space. Every new object is born in Eden space. Most objects die here. If an object survives multiple minor GC, then it moves to survivor space. Here, objects keep bouncing between S0 and S1. Once the age of that object increases and it survives multiple GC cycle, then it moves to old generation. Here, all the long-lived objects are stored. Major and full GC happen over here, and it is more expensive to clean objects from old generation. Let's summarize the memory flow now. Object is created in Eden space, survive multiple minor GCs, it moves to survivor space. Once the object is survive few more GCs, it moves to old generation space, and eventually GC cleaned it up once it is unused. Now let's understand Metaspace. Before Java 8, we had something called PermGen. It caused a lot of pain, especially in real-world application. PermGen had a fixed maximum size. It did not grow automatically. Its default size was small, and if it filled up, we used to get out-of-memory error, PermGen space. For Metaspace, we do not get this error unless native memory is exhausted. So what is Metaspace? It stores class metadata, method info, constant pool. Lives in native memory and not in heap. It is dynamically resizable. So here, if you see, this is the Metaspace. So in stack memory, we store the reference of the object, and in heap memory, we store the object. Here we have reference of object O. This is one reference, this is another reference of object O, and this is one reference of P. Right? Now, here we are storing the metadata of O and P. Let's say I'm deleting this object from heap memory. If I delete this object from heap memory, so the reference will be deleted. Now, still these metadata of O will remain in the Metaspace. There is another object, right? If we delete this object O now, then JVM will delete this metadata of object O from the Metaspace, right? So this is the way how Metaspace works. So once we load some object into the heap memory, then that object, all the class metadata, method info, everything will be stored inside Metaspace. So if your application loads classes dynamically, like in Spring Hibernate, Metaspace management becomes critical. So this was our first part of Java garbage collection series. Here we have built the foundation by understanding stack, heap, and Metaspace. In the next video, we will go deeper into understanding how garbage collection actually works, some GC strategies, and why some GC actually pauses your application. So if you like this video, please hit that like button and subscribe to my channel so that when I'll upload the next video in this series, you will get a notification. Thank you.